We've got a small server estate that's very low utilized, but massively over provisioned on RAM because someone someday, 10 years ago, bought a server and went, stick 2 terabytes in it. And it's like, how much are you using? 200 gig. And it's like, you've got 10 times more RAM than you need, even at peak. So can you just take out half your RAM, please?
Hello, folks. Great to be probably the first or second episode. I think it will be the first one. We'll see what's going to happen in the future. I'm really happy to have our first guest, Richard, who's really interesting. He's done a lot of things, and he's going to talk about that in a second. But apart from that, you can expect a new episode from about every two weeks or so. We're going to figure that out. It's still a new concept, so we'll see. So with that, thank you, Richard, for being here. Really happy to have you on board. And maybe just start with a short introduction of yourself.
Yeah, cool. So my name's Rich Kenny. I'm the managing director of Interact. We're a machine learning based environmental consultancy that specializes in circular economy. And I'm also a visiting lecturer and research fellow at London South Bank University in the School of Engineering. So a bit of business, bit of academia, a bit of research, know a few things about a few things.
You know a few things about a few things. That's always better than most people.
I think it's better than knowing nothing about a lot of things.
So. That's fair. I think it's good to know what you don't know. That's the important thing, right? So you said you're doing a little bit of university work, but you also have a company doing sustainability AI management. Can you go and elaborate a little bit on that?
Yeah, so we've got a product that looks at the performance of enterprise IT, so servers, storage, networking. It's got the world's largest data set behind it and some very advanced mathematical models and energy calculations. And basically allows us to look at data center IT hardware and make really, really good recommendations for lower carbon compute, reconfiguration of assets, product life extension. Basically, it lets us holistically look at the IT performance of an estate and then apply very advanced techniques to reduce that output. So saving cost, energy, and carbon to do the same work better. We've done about 400 data centers now in the last 3 years, and we see on average about a 70% energy reduction, which is also quite often a 70% carbon reduction in a lot of cases as well from a scope 2 point of view. There's nothing like it on the market at the moment, and we've been doing this as a business probably 3.5, 4 years, as a research project for best part of 7.
So how do I have to think about that? Is that like a web UI that shows you how much energy you consume right now at a specific server, and then it gives you a recommendation on, like, I don't know, exchange the graphics card or disk storage or whatever?
So specifically, it looks at the configuration and what work it's capable of doing. So every time you have a variation in the configuration of the server, it is more or less efficient. It does more or less work per watt. So what we do is we apply a massive machine learning data set to any make, model, generation, configuration of any type of server, and we tell you how much work it can do, how effectively it can do it, what its utilization pathway looks like. Mm-hmm. So it's really great to be able to apply that to existing data center architecture once you've got the utilization and the config, and say you could do the same work you're doing with 2,000 servers in this way with 150 servers in this way. And this is how much energy that would use, how much carbon that'll generate, and how much work it will do. And we can do things like carbon shifting scenarios. So we can take a service application, say a CRM, that's in 20 data centers across 1,000 machines, using fractional parts of it, and say, this service is using X amount of carbon, costing this much energy. So basically your CRM is costing X to run from an energy and carbon point of view. And you could consolidate that to Z, for example. So the ability to look at service level, application level, and system level data, and then serve that service more efficiently. So we're not talking about sort of rewriting the application, because that's one step lower down the stack. We're talking about how do you do the same work more efficiently and more effectively by looking at the hardware itself and the physical asset. Right. And it's massive low hanging fruit because no one's ever done this before. So we don't see it as unusual to see, consolidation options of 60+% of just waste material. waste.
Yeah.
A lot of it is doing the same work more effectively and efficiently, and that drives huge sustainability based outcomes because you're just
Right. That makes sense.
removing stuff you don't need. The transparency bit is really important because quite often you don't know what your server can do or how it does it. You're like, I bought this, it's great, it's new, and it must be really, really effective. But the actual individual configuration, the interplay between the CPU, RAM, and the storage determines actually how good it is at doing its job and how much bang you get for your buck. And you can see, intergenerational variance of 300%. So we've
Right.
got DL360. All DL360s are pretty much the same as this generation. It's like, no, there's like a 300% variance depending on how you actually build the bill of materials.
Right. So
It's
so that
massive.
means sorry, go ahead.
No,
All
that
right.
was
All right. So I think it sounds like if it does things more efficiently, it's not only about carbon footprint, it's also about cost savings, right? So I guess that's something that is really interesting for your customers, for the enterprises buying that or the data center.
yeah,
So, so who
100%.
would be
It's
the
the first time they're saving money while working towards sustainability outcomes, other than what you would do in cloud for like green ops, where realistically you're doing financial operations and saying, I'm going to reduce carbon, but realistically, I'm reducing compute or I'm reducing wastage or removing stranded applications. We're doing the exact same thing on the hardware level and going, how do you do the same work efficiently rather than just doing it? And so you're going to get huge cost savings in the millions. You get thousands of tons of carbon reduction, and none of it has an impact on your business because you're just eradicating waste.
right? So that means your customers, I think, are mostly the data center providers, or is that like
No, primarily enterprise, truth be told,
oh
because majority of data center operators are colo or hyperscale. Really, like realistically, people have got in other people's co-located facilities. The colos are facilities managers. They're not IT specialists. They're not
yeah,
experts
sure.
in compute. They're experts in providing a good environment for that compute, which is why all the efficiency metrics geared towards data center have historically been around buildings, because it's been like, how do we build efficiently? How do we cool efficiently? How do we reduce, heat, density, all this sort of stuff? None of that addresses of why is the building there? The building's there to serve
Right.
storage and compute. And they just every colo washes their hands of that and goes, well, it's not our service. Someone else is renting the space. We're just providing the space. So you have this real unusual gap that you don't see in many businesses where the supplier has a much higher level of knowledge than the owner. So when you're talking to someone
Right.
saying, I think you should buy this server, the manufacturer tells you what to buy and the colo tells you where to put it. But in between that is the IT professional who's like, I have really no control over the situation. The IT provider doesn't tell me how good it is, and the colo doesn't tell me how to effectively run it. So what I get is my asset, and I give it to someone else to manage. And
Yeah,
so what
okay,
you
that
get is this perfect storm of nobody really trying to serve it better, and that's what we do. We come in and go, there's huge amounts of waste here.
yeah, that makes sense. So it's the people or the companies co-locating their hardware into the data center.
Yeah,
So
or
it's
running
not
their own
necessarily
or running their own data centers on premise, server
right.
rooms, cabinets. We do work sometimes with people that've got as few as 8 servers, and we might make recommendation like make recommendations about reconfiguring, change the RAM setup, switch out CPUs, things like that that can have 20, 30, 40% benefits but cost almost nothing. So it could be that, and we
Oh,
see this really
wow.
all the time, is that we've got a small server estate that's very low utilized but massively over provisioned on RAM because someone someday 10 years ago bought a server and went stick 2 terabytes in it, and it's like, how much are you using? 200 gig. And it's like, you've got 10 times more RAM than you need, even at peak. So can you just take out half your RAM, please? And it
Yeah.
sounds really counterintuitive. Like, just take out that RAM and put it to one side. And if you scale up, you can just plug it back in again next week. But you've been using this for 8 to 10 years and you haven't needed anywhere near that. But it's sitting there drawing energy, doing nothing, providing no benefit, no speed, no improvement, no performance, just hogging energy. And we look at that and go, that's unnecessary.
Yeah, and I think because you brought up the example of RAM, most people will probably think, that little bit of RAM, that can't be a lot of energy. But I mean, accumulator of a whole year, it comes down to something,
It's
especially
massive.
when you have multiple servers.
Yeah, absolutely. Like RAM can be as much as 20 or 30% of the energy use of a server sometimes from a configuration level. CPU is the main driver, up to 65% of the energy use of a server CPU. I mean, we're talking non-GPU servers. When it gets GPU, you get an order of magnitude. But the RAM can be using, 30% of the power on some of these servers. And if you're only using 10% of that, you can literally eradicate, almost 20% of the combined energy just by decommissioning either certain aspects of that RAM or just removing it and putting it on the shelf until you need it next year or the year after. But the industry is rife with over provisioning at day one to give it scale at year 5. But actually, what would be more sensible is provision for year 1 and 2 with an ability to upgrade to grow with the organization. And what you'll save is you'll decrease your carbon energy footprint year on year. You won't overpay month 1 for the asset. And then in year 2, you can buy some more RAM. In year 3, you can buy some more RAM. In year 4, you can change out the CPUs. And the CPU you're buying in year 4, by the time you need to use it, you haven't paid a 300% premium for buying the latest and greatest. So it's about effective procurement as well. You want 20 servers, fine, but buy the servers you want for year 1 and year 2, and then year 3, buy the upgrade. Like upgrade the components. Year 4, upgrade. Year 5, upgrade. Do, incremental improvement, and then you're not paying a really high sunk energy cost at year 1. But also your procurement cost really high because the second you buy it when it's new, 2 years later, it's half the price. And if you haven't used it to its fullest potential in years 1 and 2, you fundamentally get a 50% saving if you buy it in year 3. But no one thinks like that. I want to buy and forget. Do you know what I mean?
Yeah, and especially for CPUs, I think in 3 years' time, you have quite some leap. Maybe a new generation, same socket, lower TDP, something like that. Yeah. But you shot me with a 30%. I think I have to look at my server in the basement.
It's worth having a look.
You literally just shot me.
It's crazy, and like we're seeing some stuff now, like where you can get persistent RAM, which actually doesn't act like RAM, but actually stores some aspects in the memory. Yeah. That's fairly energy intensive because it's sitting there constantly using even when the system's not up. But realistically, yeah, your RAM it's a relatively big energy user. We know for every sort of degree of gigabytes, you've got an actual wattage figure for that.
Wow.
So it's not inconsequential, and that's a really easy one. That's not exactly everything we'd look at, but there's aspects of that.
So we had CPUs and we had RAM. I think CPUs are obvious. You also mentioned like graphics cards. I think if you have like a server with a lot of graphic cards, it's obvious that it's gonna use a lot of energy. You had RAM. Anything else that comes to mind? Like this, so I think hard disk drives are probably worse than SSDs and NVMe's.
Yeah, it's an interesting one. So storage is really a really fascinating one for me because I think we're moving back towards tape storage as a carbon efficient method of storage. And people always look at me and go, why would you say that? And it's like, well, if you accept the fact that 60 to 70% of data is worthless, as in like you use it once, you never use it again. And that's a pretty standard metric. I think it's as high as 90% of data doesn't get used, but 65% will never get used. And what we have is loads of people moving that to cloud, that storage, and going, right, I can now immediately access data that I don't want and will never use and will never look at. And it sits there on really high available SSDs going, I can retrieve this information that I never want instantly. Well, the SSD wears over time. Every time you read, write, every time you pass information through it, it wears, right? Like that's how flash memory works. HDDs have a much longer life cycle than SSDs, but lower performance. And your average hard drive, say it uses 6 watts an hour, and an SSD uses 4. So you go, well, okay, that's 30-40% more efficient to use SSD. And it's like, well, it is, except for there's an embodied cost of the SSD. The creation of the SSD is 10-15 times higher than the hard drive. So if you're storing data that you never use, so no one's ever using that 6-watt read and write, it just sits there with a really high sunk environmental cost until it runs out, and then you kind of might be able to reuse it, you might not. But realistically, you're going to get through 2 or 3 life cycles of SSD for every hard drive. If you never look at the data, it's worthless. You've got no benefit there, but there's a huge environmental cost from a critical raw materials and from a storage point of view. Consequently, tape, it's another great example. If you've got loads of storage on cloud and you never need it, but you've got to store it like medical data for 100 years, why are you storing data that you need for 100 years on SSD in cloud and paying per gig when you could literally back, £1 million worth of storage onto one tape and have someone like Iron Mountain run archival as a service for you? where you can say, if you need any data, we can retrieve it and pass it into your cloud instance. And there's a really good company called TES in the UK. And TES basically have this great archival system. And when I was talking to them, I was like, it really made sense of how we position system of systems thinking, where they go, well, we run tape. So we take all your long-term storage and put it on tape, but we give you an RTO of 6 hours. And you just raise a ticket going, I want information on this patient. And they retrieve it and put it into your cloud instance. So you have it immediately. No one needs that data instantaneously, but you're sitting it on NVMe storage, which has a really high environmental energy cost and financial cost to basically be readily available when you never need it. Consequently, stick it in a vault on tape for 30 years and have someone bring it when you need it. You drop your cost by 99 times and your environmental input
that makes a lot of sense. Yeah, that makes a lot of sense, especially with all the data that needs to be stored for regulatory reasons or stuff like that. And I think some people kind of try to solve that or mitigate it a little bit by implying some tiering or using some tiering technologies, going from NVMe down to HDD and eventually maybe to something like S3 or what is it? S3 Glacier?
Glacial storage for AWS.
Yeah, right. So, but I think the tape thing is still one step below that.
Yeah, I mean, you think glacial storage
writing off. And
I heard a horror story of guys moving from glacial storage as an energy and cost saving mechanism, but not understanding that you pay per file, not per watt or not per terabyte or per gig, and it costing like 6 figures to move this data over to glacial and going, it's going to save you $3,000 a year, but it's now your payback point is like 50 decades. Yes. And it's like you don't realize when you make these decisions that you go, well, actually, there's a huge egress cost there. Whereas how much would it have cost to take that data and stick it onto a tape? 100 quid, 200 quid. You'll talk about significant cost savings. And environmentally, you're not looking after the systems, you're not looking after the storage. You're using an MSP to hold that storage for you and then guarantee your retrieval within timescales you want. It's a very clever business model that I think we need to revisit of when is tape the best option. And for long-term storage, archival storage, from an energy point of view and a cost point of view, it's very clever. And sustainability-wise, it's a real win. So yeah, tape as a service. It's a thing. You heard it here first. It's what people are going to be doing.
I like that. TAAS, tape as a service.
Tape as a service.
So going from super old technology to a little bit newer stuff, like what would drive sustainability in terms of new technologies? I hinted at lower TDPs for new CPUs. Probably the same goes for RAM. I think the chips get lower in wattage or watt usage over time. Are there any other like specific factors?
Yeah, I think the big one for me is that the new DDR5 RAM is really good. Like it unlocks a lot of potential at the CPU level, as in like the actual most recent jump in efficiency is not coming from CPUs. Moore's law slowed down in 2015. I still think it's not hitting the level it was. The next generation for us is ASIC based, as in application specific chips, basically. Because I think realistically, there's not much further the CPU can go. It can still go. We can still get some more juice out of it, but we're not doubling every 2 years. So the CPU is not where it's at, whereas the ASIC is very much where it's at now, like specific chips built for a specific function, like Google's VSOs, for example. They're entirely geared towards encoding for YouTube, 100 times more efficient than a CPU or a GPU at doing that task. And we saw the rise of the ASIC through Bitcoin, right? Like specific mining ASICs. So I think specificity around chips is really, really good. New RAM is decent. Very, very good. The GPU wars is an interesting one for me because we've got GPUs, but there's no really definable benchmark for comparison of how good a GPU is other than total work. So we have this thing where it's like, how much total grunt do you have? But we don't really have metrics of how much grunt per watt, because GPUs have always been one of those things we power supercomputers with. So, it does a million flops and this many MIPS and all the rest of it. And we go, but how good does it do it? How good is it at doing its job? It's like, that's irrelevant. It's how much total work it can do.
Yeah.
Like, right, so we need a rebalancing of that. And I don't, that's not there yet, but I think it'll come soon so we can understand what GPU specific functions are. I think the real big change for us is behavioral change now. I don't think it's technology. I think understanding how we use our assets, visualizing use in terms of non-economic measures. So, basically being decent digital citizens, I think is the next step.
Mhm.
I don't think it's a technological revolution. I think it's an ethical revolution, where people are going to apply grown-up thinking to technology problems rather than expecting technology to solve every problem. So yeah, I mean there are incremental changes. We've got some good stuff, but realistically, the next step of evolution is how we apply our human brains to solve technological problems rather than throw technology at problems and hope for the solution.
I like that. I think it's a general or a really important thing in general that we try not to just throw technology at problems and or even worse, creating technology in search for a problem, right?
Yeah,
I mean,
100%.
we
Yeah,
have that.
all the time. The number of times I've we're a scale up business at Interact. We do really really well. And we don't act like a scale up, but last year I was sort of mentoring some startup guys and some projects that were being done in the UK, and 90% of people were applying technology to solve a problem that didn't need solving. Like every question I would ask these people is, what does this do? What does this? And I'm like, and does the world need that? Well, it's a problem. It's like I feel like you've created a problem because you have the solution to a problem. It's a bit like it's a bit like an automatic tin opener. Do we need a diesel powered chainsaw tin opener to open tins, or do we already kind of have tin openers? Like how far do we need to innovate before it's fundamentally useless? Do you know what I mean?
Right.
And I think a lot of problems are we've got AI and we've got technology, so we've got an app for that. And it's like maybe we don't need an app for that. Maybe we need to just look at the problem and go, is it really a problem, or have you solved something that didn't need solving? And a lot of ingenuity and waste goes into solving problems that don't exist. And then conversely, there's loads of stuff out there that solves really important problems, but they get lost in the muddle. So I've seen some really, really great products when I was working with some of these startup businesses where they've got really, really good solutions, but they can't articulate the problem it's solving. And in some cases, the ones that are winning are the ones that sound very attractive. I remember there was like a med tech one that was talking about stress management, and it was like providing all these data points on what levels of stress you're dealing with, and it's kind of like that's really useful to know that I'm very stressed, but other than telling me all these psychological factors that I am feeling stressed, what is the solution on the product other than to give me data telling me that I'm really stressed? It's like, well, it doesn't do anything. It just tells you that data. And it's like, right, and then what? And then we can take that data and it'll solve the problem later on. It's like, no, you're just creating a load of data to tell me things that you don't really think has a benefit. If you've then got the solution of now with this data we can make this inference, we can solve this problem, that's really useful. But actually you're just creating a load of data and going, and what do I do with that? And you go, don't know, it's up to you. Okay, well I'm just going to look at it and say, looks like I'm struggling today. Do you know what I mean?
Right. Yeah, yeah. Unfortunately, we're out of time. I could chat about that for about an hour. You must be so happy, or you must have been so happy when the proof of work finally got removed from all of the blockchain kind of stuff. Um, anyway, thank you very much. That was very delightful. I love chatting and just laughing because you just hear all the stories from people, and especially about things you normally are not part of, right? As I said, you completely shocked me with 30%. Obviously, RAM takes energy, but I didn't know that much. So I hope that some other folks actually also learned something, and apply the little bit of ethical thinking in the future, whenever we create new startups, whenever we build new data centers, employ new hardware or anything like that.
Well, thanks, Chris.
Thank you
Thanks for
very
your time,
much.
mate. Appreciate it.